Hi, this video is going to go over estimating demand curves when you have information on slope or elasticity and some points on the demand curve. So we're going to start with a linear demand curve. So that's where Q is equal to A plus BP. And usually here, B, which is the slope of the demand curve, is negative, right? That's what we get, how we get a downward sloping demand. Now, this is the demand curve, not the inverse demand curve, and what we have graphed over here is the inverse demand curve. So to get the inverse demand curve, we want price by itself. So we have BP is equal to Q minus A, and then we can divide both sides by B, and we can rearrange that to get that price is equal to negative A over B plus 1 over B times Q. And so this term here, this 1 over B, is the slope of the inverse demand curve. And this term here is the intercept of the inverse demand curve. And that's what we have right here. All right, so the slope of this line is the slope of inverse, not the slope of the demand curve. Okay, so why don't we assume that what we have is information on the slope of the demand curve, right? So we know that B is equal to negative 2. Let's say we also have information about a particular point on the demand curve. So we know that when price is equal to 5, quantity is equal to 200, okay? So the first thing we want to do is use this information to determine what the demand curve looks like, right? So our demand curve, quantity equals A plus BP. We know that quantity is 200. We don't know what A is, but we do know that B is negative 2, and we know that price is 5. So if we multiply this out, we get 200 is equal to A minus 10, or A is equal to 210, right? So now we have all the information about the demand curve. The demand curve is quantity equals 210 minus 2 price, okay? So then how do we translate this to the inverse demand curve? For the inverse demand curve, we get price is equal to negative A over B plus 1 over B times Q. So negative A is 210, B is negative 2, plus 1 over negative 2 times Q, right? And we can simplify that. We get 105 minus 0.5 Q. So we know that our intercept is equal to 105, and the slope of the inverse demand curve is equal to negative 0.5. All right, so let's take this point we've been given, point where price is 5 and quantity is 200. So what can we do with this? Well, we can certainly calculate consumer surplus. Consumer surplus is equal to 1/2 times the height of that triangle times the base, or it's equal to 1/2 times 105 minus 5 times the base of 200, which is 1/2 times 100 times 200, or 10,000, right? So we can calculate consumer surplus. If we had another point, either just a price or just a quantity, we could use that to calculate the change in consumer surplus. So that's pretty straightforward, hopefully. So take a look at that, make sure you understand it, and once you do, let's move on. Okay, we're going to move on to another linear demand curve. So we have that quantity is equal to A plus BP. And for the inverse demand curve, we get that price is equal to negative A over B plus 1 over B times Q. Okay, and so now let's assume that instead of knowing the slope, what we're given is the elasticity for a particular point, all right? So we're going to get this point here, and let's say for this point, we know that the elasticity is equal to negative 0.12, all right? We also know what price is at this point. Let's say we know that price is equal to 0.81 and quantity is equal to 2.62. Okay, how can we use this information to help us calculate consumer surplus? Well, if we know elasticity, then we know the slope of the demand curve at a particular point. So remember that elasticity is equal to the percentage change in quantity over the percentage change in price. And I can rewrite this. So it's equal to the change in quantity over the change in price times price over quantity, right? So this first term here, change in quantity over change in price, well, that's the same as the slope of the demand curve, right? Because the slope of the demand curve is going to tell us what the change in quantity is for a given change in price. So that's our B term. Right? So if we have the elasticity and a particular point, then we can calculate what B is. All right? So if we know that the elasticity is negative 0.12, then that's equal to B, right? Whatever B is times price over quantity. And we know in this case that price is equal to 0.81 and quantity is equal to 2.62. All right, so we can rearrange this. We can get then that B is equal to negative 0.12 times 2.62 divided by 0.81. And that together is equal to about negative 0.4. So now we know what B is, right? So in our demand curve, quantity equals A minus 0.4 times P. All right, now we've got to, of course, calculate what A is. It's a pretty messy looking A. And so we can use, once again, our information about this 2 points, right, our quantity. So quantity is 2.62, and that is equal to A minus 0.4 times 0.81, right? So then we get that A is equal to 2.62 minus 0.4 times 0.81, or equal to approximately 2.3, right? So we now have A and B, and from that we can calculate what the intercept is. The intercept is negative A over B, or 2.3, negative 2.3 over negative 0.4, and that is approximately equal to 5.75. So for this point, of course, we can then calculate consumer surplus. Consumer surplus is equal to 1/2 times the height, which is 5.75 minus 0.81 times the base, which is 2.62, which is roughly equal to about 6.47. Okay, so hopefully you have that down. So now we're going to move on to our last case, our case where the demand is not linear, but instead has a constant elasticity. So what that, of course, is going to look very different. So let me clear this board. Okay, so when we have a constant elasticity of demand, instead of having a linear curve, we have a curved demand curve. And the function of the curves looks very different. And so what we have here is that the quantity demanded is a function of an intercept term, which is multiplied times the price, and the price is taken to the elasticity, right? So E here is equal to elasticity with the same definition as before, the change in quantity, percentage change in quantity over the percentage change in price. Okay, So it's important here that now if you want to calculate consumer surplus, you need to have the elasticity, this constant elasticity. There is no slope term. And you also will need to have at least 2 points, right? And so for a constant elasticity demand curve, you can estimate the change in consumer surplus between 2 points as being the price and times the quantity at 1 point minus the price times the quantity at the second point divided over 1 plus the elasticity, right? So this is a formula. You don't need to derive this formula. Basically, I'm telling you that if you have a constant elasticity of demand curve and you know both the elasticity and the before and after prices, you can calculate the change in consumer surplus using this formula. All right, and so what you need to have is the elasticity and 2 points. So using the example from the book, let's assume that elasticity is equal to negative 0.15, and that we have 2 points. We have P0 equals 0.05 and Q0 equals 2.25, and then we also know that P1 equals 0.08 and Q1 equals, well, we can actually calculate this. So what you need to know is you need to have an initial starting point and the elasticity term, and then you need to know what is the price change, so you can then calculate the quantity associated with that price change and the consumer surplus. Okay, so let's start with these two pieces of information. From these two pieces of information, we can figure out what the demand curve looks like, right? So we know that Q is equal to A times P to the elasticity, but we can also then define A in terms of the elasticity level, Q, right, divided by P to the elasticity, right? And so for a given elasticity and a given quantity and price, we can calculate A. So in this example, we can use the quantity of 2.25 divided by 0.05 to the negative 0.15. And if you get your handy dandy calculator out, you'll find that that's approximately equal to 1.44. Okay, so now we know what the functional form is. Quantity is equal to 1.44 times P to the negative 0.15. Now we can figure out what Q1 is by substituting in the P1 of 0.08, taking it to the negative 0.15, and we get that Q1 is equal to, let's see, approximately 2.1. All right, and now we're ready to calculate the change in consumer surplus. It's equal to 0.08 times 2.1 minus 0.05 times 2.25 all over 1 plus the elasticity, which is negative, so negative 0.15, and this is approximately equal to 0.0653. All right, so if we have, once again, a constant elasticity of demand curve, and we know the elasticity, and we know a particular starting point in terms of price and quantity, and we can estimate the price change, then from that we can derive the quantity change as well as the change in consumer surplus. Okay, so those are the only kinds of examples that you would encounter for this class in an exam, and likely the only examples you would ever encounter in real life if you had information limited information on a demand curve so that you couldn't do a demand regression, but you still wanted to calculate consumer surplus. So hopefully this made sense to you. Look over it, review it, and if you have any questions, come see me in my office. Okay, thanks.